For the next example problem, now we'll be modeling the entire I-90 facility. So all segments that we have analyzed individually now will be analyzed in a single file as a single corridor. So let's get started by opening our Freeway module. Let's open a new file. And now let's start a new Freeway facility. You'll notice there are several pages here, so this module is more data intensive than the others we have studied so far. And we will start by going to the segments page. And there are two ways of entering my segments. One of them is adding segments manually, one by clicking Add Segment. And then for each row in the table, I can select the proper segment type, their lengths and number of lanes. But for this example, I want to try a different approach, which will be clicking on the map-based segmentation, because we will draw our freeway based on map view. So we can hit OK here. And once you see this window, you are able to draw your freeway by pinging nodes on the map. For example, let's look for Madison, Wisconsin, which is where our facility is. You can hit OK. I would suggest always changing to the aerial view, because this is helpful to find the pavement markings where we can set our segment boundaries. And let me bring the map again. If I zoom out a little bit, you'll notice that my freeway that I was studying is located to the east of these two lakes, which is exactly the point where I will be working. So for the map page, if you want to move slightly east, you'll find the starting point. So let me make sure that everything can be seen in a single screen. So let's zoom in a little bit here, and let's find the starting point here on the map and also on HCS. So if you see this Cottage Grove Road, that means you're in the right place. Let's zoom in a little bit more. So let's remember we're modeling the northbound direction. So let's find the corresponding point over here. And the way to get started, you right click on the freeway, and you always start a freeway with a freeway node. And you should also always end with a freeway node. And in the middle, you can add as many nodes as you would like to. And what we'll be doing next, for each one of the nodes you see on the map over here, we'll be adding an equivalent node on the map, which will represent all my on-ramp and off-ramp points. So the first one would be right here at the beginning of my interchange. You'll see here I have my off-ramp located on the left side. We can zoom in a little bit here. And let's find the diverge point where the channelizing lines meet over here. Right-click on the freeway, never on the ramp, and add an off-ramp node. You'll notice that the table here on the left side of my screen automatically is filled because it populates the list of segments based on the nodes that I have dropped. The next one will be this off-ramp to I-94 eastbound, which is another off-ramp, but located on the right side of my screen. Again, we will find the corresponding diverge point. And I just want to illustrate what would happen if you misplace the node. So instead of placing this on the main line, you place on the ramp. Let's proceed to the next node, which will be this left-hand on-ramp over here. So let's keep moving forward. Let's find the corresponding merge point, the end of the solid line over here. Right-click on the main line, add an on-ramp node. And let me zoom out to see what happened when I misplace a node. you see one of my lamps was added with a very long distance, over 90,000 feet. And that's because I misplaced that node. So the map understands that I have taken the wrong exit and I have to drive all the way back to get to the same freeway point. If that happens, that's an easy fix. Just go to the wrong spot, left click and hold, and drag it back to the main line. And if you see one smooth center line, that means you're doing it correctly. Let's keep moving forward. The next point here will be the beginning of my weaving segment we previously analyzed. So let's find the same spot on the map, which is going to be around here. Let's find the end of the line, the solid line, right click on the main line and add an on-ramp node. Let's also make sure that for this node number 5, we have 2 ramp lanes. So let's change this accordingly. And then let's keep traveling north. The next node will be located at the off ramp at the downstream end of my weaving segment. So again, let's repeat the process over here. Let's zoom out around here. If you see this exit 135 ABC, that is the right spot. Let's find the diverge point over here. Right click on the freeway, add an off-ramp node. And again, let's change number of lanes to 2 to be consistent with the map. Let's look at the map again. And here you'll notice there is a cloverleaf interchange, but we're going to skip that because if you look closely, that's a parallel road. So that's a collector distributor road here, which is not part of the facility that we're analyzing. So we're going to skip that part. And our next node will be located right here on ramp from US 51 downstream of the interchange. Let me repeat that process. So my merge should be located around here. Let me find the correct spot, right click on the freeway, add an on-ramp node. And finally, we're going to finish our facility at the end point here. Let's find the corresponding spot, which will be close to this roundabout. So right click where you want to end your facility and add here another freeway node. And this will finish my list of nodes. You may have noticed that we have a weaving in the middle, but we don't have an option to add a weaving. We only add on-ramp and off-ramp nodes. How you model a weaving segment here? HCS recognize a weaving segment when 2 conditions are met. First, you need to have an on-ramp followed by an off-ramp, and that's what we have over here. And also the segment in between those 2 ramps, the number of lanes here must be 1 greater than the upstream and downstream segments. And let's remember, we have 4 lanes here in this segment. And we have upstream segment with 3 lanes, downstream segment with 3 lanes. And once those 2 conditions are met, you can just hit OK. And this segment will be automatically be modeled as a weaving. We can hit OK. It will ask for confirmation because it's going to overwrite anything we have previously modeled. And we are done with our modeling process. The only thing we need to do right now, let's make sure our ramps are located on the right side or the left side. So for the segment number 2, diverge, we can click on the segment or go to the details page. Let's change this to left. And also segment number 5, let's also change this to left. And with that, we should be done with this first step of modeling our facility. So just to summarize what we have done here, We started with this facility. We took our measurements, which corresponds to placing those nodes on the map, and the software automatically applied the segmentation rules to create a list of segments that would look something like this in the bottom. You may notice the segment lengths at the end, they don't exactly match the initial measurements because certain rules are applied. For example, the weaving segment, the segment is 1,000 feet longer than the measurement because we are adding 500 feet on each end, which is part of the segmentation process. And of course, these 500 feet on each side are being deducted from the adjacent segments. Merge and divert segments, they are modeled with the default value of 1,500 feet whenever applicable, and everything else is modeled as a basic segment. And whenever the segment merge or divert is too short and you don't have enough space, you'll be using whatever length is available, which is the case of the segment this diverge here, which uses the available space of 725 feet, and that will be the segment length. Of course, because this is done graphically, your numbers may be slightly different from what we have here, but this can also be adjusted in the software if you like a more accurate modeling. And with that, we're done with our first part. Next, we'll proceed to enter additional inputs, including additional geometric factors and track volumes. For the second part of our example problem, let's finish modeling our geometric inputs. So we have our facility, as you can see over here, and we still want to add a few additional inputs. Let's model our acceleration, deceleration lane lengths. If you haven't yet, we need to set a few segments to be a left-hand ramp. We also need to model our weaving inputs. And we also need to set our free flow speed for all segments, both mainline and the ramps. So in order to do that, let's get back to our software. Let's start with all ramps, starting with segment number 2. If you haven't yet, change this to the left side. Let's change the length of the first acceleration lane length to 300. Segment number 3, the diverge. Let's make sure we set our deceleration lane length to 175 feet. Segment number 5, the merge. Depending on how you model, you may notice there is an error on the top right when it turns red. And if we check it here, you'll see that I get this error message saying the acceleration lane length is longer than the segment length for merge segment number 5. There is an internal rule in HCS that the acceleration lane length cannot exceed the segment length. So in the problem statement, we have a suggested length of 550 feet. But depending on how you place your nodes, your segment length may be slightly smaller or higher. So in order to fix that error, make sure that whatever you enter here does not exceed the segment length. So in this case, I will enter 533 feet. And you notice now I fix my error. So make sure you do that depending on the length that you got in your segment. And finally, let's make sure segment number 8, the merge, we have a length of 1,250 feet. Next, let's focus on our weaving segment. Let's enter our geometric inputs. We have 0 freeway to ramp lane changes at minimum, 1 ramp to freeway lane changes at minimum, and we have 3 weaving lanes over here as we modeled previously. Let's set our short length to 7,350 feet and an interchange density of 0.33 interchanges per mile that accounts for 2 nearby interchanges. If you enter the number of ramp lanes correctly during the segmentation process, you should already see 2 and 2 lanes. And with that, the last step we need here for our geometry, you also need to set our free flow speeds. So every ramp is going to have a free flow speed of 35, which is already the default value, so we don't really have to touch that. But we also need to set our free flow speed for every segment to 68 miles per hour, as you can see over here. One way of doing that would be entering this value manually for every segment, but that's not really very efficient. So let's focus on our global inputs, which can be found under the general page. So whenever you need to assign a certain parameter to the entire facility, you can do it through the global inputs. And in this case, I want to check my free flow speed, set the number that I want to assign to my facility, and I can hit apply global inputs. Since we are here in this page, we may also want to go ahead and check total trucks, 17% for both freeway and ramp, because this will be something that we'll be doing in the next part, but we can just save ourselves some time here. So let's keep those three checked, apply global inputs. Let's hit yes. And you'll notice that now every single segment here has a free flow speed of 68 miles per hour. Every single segment also will have 17% trucks, both freeway and ramp when applicable. And with that, we're done with part 2. Next, we'll proceed to modeling our traffic volumes. Next, in our example problem, we now need to model our demand volumes. So first, let's get back to the segments page, and we want to model 1 hour of operation between 7 and 8. And for this study, we'll be doing a multi-period analysis, which means instead of entering one volume representing the hour, we're going to enter 4 different sets of volumes, each one representing a 15-minute period. So we'll be doing 4 different analyses in our freeway facility. So how we do that? Let's get back to the model, and you see here the analysis period. By default, any new file will start with a single analysis period. We can add multiple analysis periods by clicking the button here, repeat the process until we see 4 different analysis periods. That means we are studying 1 hour, and the duration of each period is set to 15 minutes, and that cannot be changed. You can change the start time. So given the start time at 7 and 4 periods, that means I have modeled my scope of analysis to study the entire hour between 7 and 8. And then next, we'll start modeling our volumes. You'll notice that the first segment allows you to enter the entering demand volume. You'll see that I cannot enter for the other segments. So I have an entering volume of 38 and 20. And you'll notice that this is automatically filled for every segment because the freeway is assumed to have full access control. So unless there are vehicles entering or leaving the freeway through ramps, volume will stay constant. If you have the latest HCS version, you will also be able to enter the ramp demands. So for example, segment number 2, we have an exiting volume of 225. And you'll notice the downstream segments, they have their demands adjusted automatically. Segment 3, 465. Segment 5, the merge, we have an entering volume of 810. And segment number 8, the merge, we have a volume of 652. If you don't have this feature here, this column ramp demand, you can also go to the segment and you can enter that demand over here. So you can do this on a segment by segment basis. Let's also enter our weaving segment volumes. You'll notice that freeway to freeway is disabled. It's computed automatically based on the upstream volumes, so we can focus on the others. So ramp to freeway, 910, ramp to ramp, 133, freeway to ramp, 1422. And with that, we're done with our first analysis period. We're going to repeat the process for the other 3 analysis periods until we're done. For the rest, let me show another alternative how to model traffic volumes, especially if you have a long facility with multiple time periods. This may not be the most efficient way of entering data. So another way you may want to consider is you can also export your facility to a CSV file, which is a spreadsheet that can be opened through Excel. Let's save this in our computer. So save in a location where you can easily find that. And then let's open our spreadsheet over here. And this spreadsheet will have every single parameter that's used in your freeway analysis. So we have here our list of segments. Let me freeze this view so we can just get a better sense of what we're modeling. And now you can see you can enter all your inputs for a spreadsheet if, let's say, you keep another spreadsheet with all your volumes, or if you play with several scenarios. For example, we're going to enter our mainline demand. We enter the first, and then we can enter the other 3 analysis periods. So make sure when you export, you have already entered all your analysis periods, because that changes the file structure. So here, just in case you would like to get those volumes, you'll see available in the course platform under the support files. You have a spreadsheet with all the volumes. So if you prefer to copy and paste, you can also do so. So in this example, let me find first the entering volumes. So that will be row number 68 here on my spreadsheet. I'm going to copy these numbers and I will paste it here. Don't need to worry about formatting. All formatting is lost when I save this CSV file. Let's keep scrolling down. And let's find this field called ramp demand TR1, which here is row number 218. And here you see my segments. I entered the first period. Now let's go ahead and work the others. So segment number 2, segment number 3, segment number 5, and segment number 8. And finally, I need to model my weaving volumes, which will be right here, row 277. We have 3 different volumes that we need to enter for my weaving, starting with ramp to freeway over here, ramp to ramp. It's going to be this one, and freeway to ramp. And now that we're done entering those volumes, let's make sure we save our file and we can close it. And as you may guess, the last step here, we're going to import that file back into HCS. So let's do the other way around. Let's find our file over here. It will ask you to save your file. And you'll notice that every single time period was automatically modeled here. You also notice that once we enter all those volumes, peak hour factor is disabled and is set to 1. And that's because of the HCM principles. Once you're doing multi-period analysis, the peak hour factor is not required because you're entering the actual 15-minute volume, so you don't have to adjust for traffic peaking. And with that, we can go to our report. We can check our heat map report. And overall, you can see in the heat map, everything is looking good. Level of service, everything around B and D. We have additional measures for such as speed, density, demand to capacity ratio. Let's make sure nothing exceeds 1 here. And you also have the ability to add additional tables if you like to get extra information. For example, the volume to capacity ratio. In this case, it's the same, but if you have oversaturated conditions, that may not be the case. Density in vehicles instead of passenger cars, density in the ramp influence area, density-based level of service, or demand-based level of service, which will only turn F if demand exceeds capacity here. And with that, we're done with this second part. The last part we're going to do next, we're also going to model an incident, and we're going to see how that affects our operation in our freeway. All right, for the last part of our example problem here, we also want to simulate an incident analysis. So let's say in the same facility, for the second time period, 7:15 through 7:30, we now have lane closure on segment number 7. So due to an incident, 2 out of 3 lanes are closed. So how would that affect my performance in that case? So let's go back to HCS. Let's go to details page. Let's select the proper analysis period, the second one on the list. And let's select segment number 7, basic. Let's model an incident. So it's a 2-lane closure. And based on the suggested capacity adjustment factors from HCM, the software will apply a capacity adjustment factor of 0.51, or is going to reduce 49% of the capacity of the remaining open lanes, which means you have 3 lanes, you close 2 out of 3, so you are already reducing your capacity to 1/3. And on top of that, you still reduce your capacity by almost half. So you should expect to have a final capacity about 1/6 of the total capacity of the open segment. And with that, let's check again our report. And now we can start to see some oversaturated conditions over here. So once you have oversaturated conditions, you may want to look first demand to capacity ratio to try to identify your bottlenecks. In this case, it's pretty obvious. Segment 7, second period is the bottleneck because of the closure. So demand exceeds capacity in more than 3 times. And that, of course, creates a level of service F here. And you'll notice the upstream segment is also affected by the queues. So it also yields a level of service F. And that can be noticed by the drops in speed and the spikes in density, which is a clear indication there's queuing going on. If you look at the next time period 3, you'll see the bottleneck was resolved. So the demand to capacity ratio goes back to normal. But you'll also notice that we still have some oversaturated conditions on the third time period. And that happens because the queue at the end of the second period is still clearing. So there is still some extra demand of unserved vehicles, which is still causing some operational issues. And these are the effects that can only be analyzed with the freeway facilities method. You could not capture that in a single period analysis, and that is the biggest strength of using this kind of analysis with the higher capacity manual. And with that, we're done with our freeway facilities example problem.